9.1 graphs of sine and cosine. With these graphs, they are periodic functions, which just means they're functions that repeat on a regular basis. These repetitions are called cycles, and the length of that cycle is called a period. So if we look at some examples, we're telling whether or not these are periodic or not periodic. So for like this box that we have here, we see this first graph that has a period because it starts somewhere and it stops somewhere, and then it picks up and continues to do the same thing. So the amount of space between these two points of starting and stopping is called your period. So for this one, we would have a period of 2. For this one here, it's not periodic because if you see, you can start here, but it doesn't end in the same place. So it should end in the same exact place and continue to be the same exact period or same exact cycle. Okay. So if we look at example 1, we're identifying whether each function is periodic, and if the function is periodic, we're giving the period. So for A, we have a period here because we start one place, we end, and then it literally picks back up and does the same exact thing. So what you'd be able to do, which I can't show you here, I can show you in Notability when we do your actual notes together, you can take that period, if you overlap it, you can copy it and move it, or copy it and duplicate it, and just move it to where it picks back up, and it should be exactly the same. That's how you know that this is periodic. So for here, to tell where what your period is, you're going to count the space between these two starting and stopping points. So here it is periodic, and your period is 2. For B, however, if you look here, we're going to start at one place, which is here. You go up and you go down, but this does not start here and go up and down to here. So because it doesn't repeat the same, there's not that cycle that's constantly repeating, this is not periodic. For C, we have our first line with a circle. All right, so if this was periodic, it would have literally started at the same place that it ended and have a circle. Same place that it ended, have a circle. Same place that it ended, have a circle. So because this cycle is not exactly the same, in the same position with your y values, this is not periodic. For D, we have a line that you see here that goes up with an arrow. We also have one at the end that goes down. If you were to connect these two, they would literally be this middle line here. So this is periodic. And in order to tell your period, you want to look here. You have 1, 2, 3 places that's in between these two. So your period is 3. For your next part, we're first going to start with the amplitude. Your amplitude of sine or cosine is half the distance between the maximum and the minimum values of the function. So your amplitude is always positive. So in order to find it, you're actually going to be taking the absolute value of A. If you look at these two pictures, they're the same exact thing, just drawn 2 different ways. There are 2 graphs of sine. Your sine functions are f of x, g of x, y is equal to a times sine times b times x. So your a and your b you're using to get your amplitude and your period. So with these, your period will differ, and it's the exact way from starting to stopping that you are going to have that repetition. And in order to find that, you can use the formula 2 pi over the absolute value of b. With these, they are always going to start at 0, 0. So sine always starts at 0, 0. It will go up or down to a certain stopping point, which is what your period is. The height of these going up or down is your amplitude. So with that, you should be able to draw points and be able to tell middle areas. Middle areas will always be on your x-axis with these. You can also follow these directions and it would be a lot easier for you. So first thing to do when you are graphing sine is you want to start at your 0, 0. That's going to be your first point. You want to identify your amplitude and your period. Then you want to plot the next point using the period. So it will be on your x-axis and it will be your 0, 0 and then that point. From there, you want to plot the point that's halfway between those 2 points on your x-axis. Then you want to use your amplitudes to plot the next 2 points going up and going down. Your up will be in the middle of the first 2 points, so the first point and the middle point. Your down will be between the middle point and your period point. From there, you just want to repeat the period to the left or to the right to cover the entire coordinate plane. So if we look at our first example, again, we're going to first find the amplitude and the period. So for A, we have g of x is equal to 3 sine 2x. So your A is that 3. Your B is the 2. So from here, to get your amplitude, you're going to take the absolute value of A, which is the absolute value of 3, which is just 3. So this tells you your height. So your height's going to go all the way up to this 3 and go all the way down to this negative 3. For your period, you have the formula 2 pi times the absolute value of B. So if this is 2 pi times over the absolute value of B, this is going to be 2 pi over, your B is 2, so the absolute value of 2. This is just 2 pi over 2, which is just pi. So you know that you're going to be stopping at pi and at 2 pi if you were to repeat. So first point here is your origin. That's 0, 0 point. From there, you want to put a point on your period, which is pi. Then you want that halfway point, which is 1/2 pi, or pi over 2. From there, use your amplitude. This middle dash between your origin and the middle point, that pi over 2, is going to be the y value of that amplitude, which is 3. So your first point that you're going to have here that's going to go up is going to be here. Then the middle point between your middle and your last point, which is where your period is, that pi, it's going to go down to negative 3. From there, you can draw your line. So it's going to go up through that middle point, down to that period point. Then from here, it's just going to repeat. So you want to do 1 at 2 pi, do 1 in the middle, go halfway between, go up to 3, go halfway between the middle and your period, go down to negative 3. And then just continue going up, then through the middle, down into 2 pi, I'm sorry. You want to also go to the left of these as well. So instead of it being pi, you're just going to go to negative pi. Halfway between there would be this negative pi over 2. Between the 0, 0 and the negative pi over 2, you're going to go up to 3. Plot that point. And then between the pi over 2, the negative pi over 2 and the negative pi, you're going to go down to negative 3. So from here, you're going to go down first. I'm sorry. These are opposite. So this is going to go down. You want to repeat the period or that cycle. So it's going to go down and go up. Let's do this a little bit better. Go down and up to the period. So then do that again. All the way, halfway, go down, halfway between that, go up, halfway between those two, go down, go up, and then stop. And then if you wanted to keep continuing this to go off the graph, you could do so as well. You would just have a point up here and a point here. So you can go up and down. It's going to be a point here and a point here. So go down and up. And then you're done. For b, we have g of x is equal to sine 2x. So our a is just 1. There's no value in front of sine, so it's just 1. So 1 is your a. So we have an amplitude of 1. Your b is the 2. So from here, our amplitude is the absolute value of a, which is the absolute value of 1. Your period is 2 pi over the absolute value of b, which is 2 pi over the absolute value of 2, which is just 2 pi over 2, and that's pi. So, first thing, plot the 0, 0. Second, plot your period. From there, where's your halfway point? Your halfway point is pi over 2. From your origin, you're going to go up your amplitude. Your amplitude is 1, so your highest point here is going to be 1. Your lowest is going to be negative 1. And then if you wanted to duplicate this, just do it again. The 2 pi is your period. Half of that is 3 pi over 4. And then you're going to go half of that, go up to 1, go between your halfway point and your period point, and go down to negative 1. Then just repeat. And then you want to do this on the other side too, but when you do this, remember, you're going all the way, halfway, you're going to go down first, then up. So it's going to go down, then up, and then you're done. And then you go do it again. Halfway, halfway of that, go down halfway of that, and halfway between your halfway point and your period, go up. And then just complete it. And you're done. For c, we have g of x is equal to negative 2 sine 3x. So our a is the negative 2, and our b is the 3. So for this one, we have an amplitude of the absolute value of a, which is the absolute value of negative 2, which is just 2. And a period of 2 pi over the absolute value of b, which is 2 pi over the absolute value of 3, and that's 2 pi over 3. One other thing that you want to keep in mind when you are doing this specific function is that negative that's in front of that 2. So we want to take this negative and make a note on it. You want to remember reflection. So with this, when you start it, yes, you're still starting at that origin, but you are going down and then up instead of starting out going up from that origin. So look at your points that you're going to be using. So we're going to start at the origin, we said. From here, we're going 2 pi over 3. So again, this middle point here is half pi. So 2 pi over 3 is just past that. And then we would have to go about here, and then about here. And then we're going to do the opposite direction as well. Okay, so with these, we're first going to go down. And when we go down, we're going to go to that negative 2. And then we're going to go up as well to that positive 2. So our graph is going to go, or our line's going to go down and then go up to come back to that next point. Then continue doing this. We're going to go down first, then we go up. So we're going to go down, then up, back to that point on our x-axis. Same thing. And then we're just going to keep doing the same thing until we get through our entire coordinate plane. And we're going to go the opposite way as well. So we're going to go up first. We'll go up first, then we'll go down, moving to the left. So up, then down, through that center point on that x-axis. Then go up again, and down to the axis. And then just keep going through your entire coordinate plane. Oops. Do that all over again. And then you're done. For D, we are given g of x is equal to 1/2 sine 1/2 x. So our A is this 1/2, our B is this 1/2. So if we are to find our period, it is just the absolute value of A, which is the absolute value of 1/2, which is 1/2. Our amplitude, we're going to find by using 2 pi over the absolute value of B. So that's 2 pi over the absolute value of 1/2. So it's 2 pi over 1 divided by 1/2, which is just 2 pi times 2, which is 4 pi. So when we do this, we want to keep in mind that this 4 pi is a large distance between the origin and your next point that's going to cross over that x-axis. So we're going to start on your x-axis. That halfway point is going to be that 2 pi. So yes, the 2 pi is going to be a ordered pair that you're going to use on the x-axis, but it's only going to be a halfway point. So we want to think to ourselves, where is our period? So, or sorry, your amplitude, these are switched. Your amplitude is your 1/2. I'm sorry. Your amplitude is your 1/2. Your period is your 4 pi. So, I'm going to do it again too. Amplitude, period. Alright, so your period is at 4 pi, which means the half of that is the 2 pi. Your amplitude is the 1/2. So between the halfway point of this, you are going to go up to 1/2 and have your first point. Then if you go another halfway between your middle and your ending point for this period, you're going to go down to negative 1/2. So this graph is going to just curve slightly, and you're going to do the same thing on the other side. So it's going to go down to negative 1/2 at negative pi, and then be at your origin or at your axis at negative 2 pi. And go down. And then you're done. For cosine. Cosine is very similar to sine with your period and your amplitude. However, the starting point is always going to be on the y-axis where your amplitude is. So with these, in order to find your amplitude, it's still the absolute value of A. And in order to find your period, it's still 2 pi over the absolute value of B. With these, though, you are going to start at your first point of the amplitude, 0. So with these, your amplitude, whatever that A is, will tell you where to start on your y-axis. Okay. From there, that's going to be your highest or your lowest point. So if the function is y is equal to A, it's going to be a positive, then the first point will be at 0, positive number. For a negative, it's going to be a negative number, so it'll go down first. From there, you're going to plot the next point using your period and your amplitude. that's going to be your lowest or highest point. Then you plot the point halfway between that and the first point and the middle point on the x-axis. Plot the next point between the middle point and the last point on the x-axis. Then repeat the period left or right, and to cover the entire coordinate plane. So you're doing practically the same thing, except you're just starting at a different position now. So if we look at example 3a, we have h of x is equal to 1/3 cosine 2x. So our a is the 1/3, our b is the 2. So our amplitude is the absolute value of a, which is the absolute value of 1/3, which is just 1/3. This gives us the first ordered pair of 0, 1/3. Oops, not 13. Your period, so the length side to side, is 2 pi over the absolute value of b, which is 2 pi over the absolute value of 2. And that's just going to be 2 pi over 2, which is pi. So from here, first point, that 0, 1/3. That 0, 1/3 is about here. So from there, we want to do our period point. So that's going to be the period, which is pi, comma, 1/3. So halfway between this point is that pi over 2. So we're going to go down to that negative 1/3 underneath there and plot that point. From there, halfway between those two is going to be on the x-axis, and then halfway between the middle point and your period point will be on the x-axis. And then we're just going to repeat. So we're starting at the pi, comma, 1/3. We're going to go to 2 pi, comma, 1/3. That's going to be our ending point. The point between these will be our lowest point. So it's going to be the middle point from between pi and 2 pi, and go down 1/3 and plot the point. So then your middle points would be on the x-axis there. So your line's just going to look like this. And then you're going to do the same thing on the other side. So on this one, though, you're going to go down and to the left. So it's going to be the same exact thing as what you did just now. Lowest point is the negative 1/3. So down and up, down and up. For b, we have h of x is equal to cosine 2/3 x. So our a here is 1 because there isn't a number in front of the cosine. So a is 1. Our b is the 2/3. So our amplitude is the absolute value of 1, which is just 1. And your period is 2 pi over the absolute value of b, which is 2/3. Remember, this is 2 pi divided by 2/3, which is 2 pi times 3 over 2. The 2's would cancel, so it's just 3 pi. So, first point is this 1, comma, what? The first point is 0, 1. Your next point is the 3 pi, comma, 1. This is 0, 1. This is 1, 3 pi. The other way around. 3 pi, 1. Your amplitude is always your y. 3 pi, 1. Alright, so this is half, so then 3 pi would be about here. So your first point we're going to do at this 0, 1. Your second point we're going to do at 3 pi, 1. So it's about here. The point in the middle of these 2 points that you just drew is going to be in between pi and 2 pi, so 1.5 pi, and it's going to go down to negative 1. From here, if you need to go ahead and draw the middle points between those, you can, but you don't need to. So you're just going to have a line that looks like this. And then you're going do it on the other side of this as well. Oops, let's do this one more time. And then you're done. For C, we have h of x is equal to negative 2 cosine 3x. So our A is that negative 2, our B is the 3. So our amplitude is the absolute value of negative 2, which is 2. And our period is 2 pi over the absolute value of B, which is 2 pi over 3. So when we go to graph our first point here, again, we have this reflection that's in front of this 2. So we want to reflect before we start doing this. So our first point is not going to be that positive 2. It's going to be that negative 2 on the y-axis. So we're going to have our first point at the negative 2, and then we're going to go up from there. So with this, you have a period of 2 pi over 3. So 2 pi over 3 is going to be about here, and it's going to be in line with that first point that you would draw, or that you would graph. Then you have your next. And you're going to go the same direction in the opposite way. And then these are just going to go up from here. And then halfway point is going to be at positive 2. So you're just going to go up to positive 2, then back down to the negative 2. And you're just going to do this for your entire coordinate plane. And then do the same thing going the opposite direction. So you're going to go up to positive 2, then back down to negative 2. Up to positive 2, back down to negative 2. Up to positive 2, back down to negative 2. Up to positive 2, back down. For D, we're given h of x is equal to 3 cosine 4x. So our A is that 3, our B is that 4. Our amplitude is the absolute value of 3, which is just 3. And our period is 2 pi over the absolute value of B, which is just 2 pi over the absolute value of 4, which is 4. So this simplifies to be pi over 2. So our period is that pi over 2. Our amplitude is that 3. So we're going to start at 3 on the y-axis. And then we're going to go half of the pi to get to our next y value. And then we go full. And then half again. And then 2 pi 3. For all of these halfway points, you're going to be down. So you're going to have pi over 4, comma negative 3. Then you'll be 3 pi over 4, negative 3, 1 1/4 pi over 3, or comma 3, so on. And then you're going to do the same thing in the opposite direction. So half, full, half, full. And then you're going to do the bottom points as well, so the negative 3 points. Oops. So then these again are just the quarter points that you, or the quarter values that you have there. So starting at that 3, we are going to go down and then back up. And this is just going to be very, very narrow. And then going to the left, we're going to go down first. And go up. Go down. And then up. And then you're done. For part 4 of your notes, we are identifying phase shifts and vertical shifts for sine and cosine functions. So with these, you can use your formula y is equal to a sine b times x minus h plus k. However, there's a much easier formula to use because you are going to use the values within this formula. So you can also use y is equal to a sine b of x, or sorry, b times x minus c. So with this, you can pick out your b and your c. This works for cosine as well. Your b and your c are actually going to give you your shifts, your phase, like your phase shift. So your shift is actually equal to c divided by b. So with these, you can go ahead and use those two values if they're in parentheses, the coefficient of x and the constant, to find your phase shift. So with this, if we look at example A, we have y is equal to sine times x minus pi over 3. So for this one, our amplitude comes from A, which is 1. B, we are going to use as 1 as well, because that's the coefficient of x. We don't have a coefficient of x here, so it's automatically a 1. So for our amplitude, we will have the absolute value of A, which is the absolute value of 1, which is just 1. For our period, we have 2 pi over the absolute value of B, which is just 2 pi over 1, which is 2 pi. Now, for our phase shift is C divided by B. Our B here is the 1. Our C is that pi over 3. Now, you see how there's a negative in front of that pi over 3. We're taking the opposite of that, so it is positive. So this is just pi over 3 divided by 1, which is just pi over 3. So because this is positive, this is going to be to the right pi over 3 units. So we have our amplitude is 1, our period is 2 pi, and our shift is right pi over 3 units. Now you may be wondering why we do it this way, and in example C, you're going to see why exactly we do it this way. So for B, we have f of x is equal to 4 cosine x plus pi plus 5. So this 4 is our A, we have a 1, that's B, our C is pi, and then that 5 is going to be that vertical shift. So looking at this, we have A is 4, B is 1, C is pi. So for our amplitude, it's the absolute value of A, which is the absolute value of 4, which is just 4. Our period is 2 pi over the absolute value of B, which is 1, so 2 pi over 1, which is just 2 pi. Our phase shift, our shift is going to be C divided by B. So our C value is pi, our B value was 1. Pi divided by 1 is just pi. So this also is a negative pi because this sign was a positive. So this is also a negative. So we're moving to the left pi units. From here as well, the plus 5 means that we're going up 5 units. So with these, your amplitude is 4, your period is 2 pi, your shift is left pi units, and then we are going to have a vertical shift of up 5 units as well. For C, we have y is equal to 3 minus 2 cosine x. This 3 is the same thing as saying as if it was after the 3x. So y is equal to minus 2, negative 2 cosine 3x plus 3. So there's no parentheses here, so we don't have a c value. This a is your negative 2, your b is the 3, your c you don't have one. So we are going to have a is negative 2. Let's do this in red. Do your amplitude in blue. A is negative 2, b is 3. So our amplitude is the absolute value of negative 2, which is 2. Your period is the 2 pi over the absolute value of b, which is 2 pi over the absolute value of 3, which is 2 pi over 3. Then we have this plus 3. That means that we're going up 3 units. And then we also have the negative in front, which tells us that we have a reflection. So this reflects across the x-axis. So for these, your amplitude is 2. Your period is 2 pi over 3. We're going up 3 units, and we have a reflection across the x-axis. For D, we have g of x is equal to 1/2 sine times 5x plus 2 pi minus 1. So our a is the 1/2. Our b is the 5. It's in parentheses with x, so we have a c that's negative 2 pi, and our phase or our vertical shift goes up or down by 1. So our a is 1/2, our b is 5, our c is negative 2 pi, and then we have a vertical shift, a vertical shift up or down 1. Okay, so your amplitude is the absolute value of a, so that's the absolute value of 1/2, which is just 1/2. Your period is 2 pi over the absolute value of b. Well, your b is 5, so it's 2 pi over the absolute value of 5, which is just 5. Your phase shift is c divided by b. Your c is 2 pi, your b is 5. So that's 2 pi over 5, and that's a negative 2 pi. So this means that we are going to the left 2 pi over 5 units. And lastly, that negative 1, that minus 1 means that we're going down 1 unit. So we have an amplitude of 1/2, a period of 2 pi over 5, and a horizontal shift left 2 pi over 5 units, as well as going down 1.